Welcome to section 6.2 on the simplex method. The method itself is not very complicated. It is long, it's tedious, it's very easy to make a mistake. So take your time, make all of your calculations slowly and precisely. This first page is a flow chart on the basic method. So let's just look at some important parts. Step one is to put all of our constraints and thing to optimize in a form that I can put it into a matrix. Step two, we look at the very bottom row. Does the bottom row have any negative numbers in it? If the answer is no, we're done. If the answer is yes, all right. So then I have to figure out, well, what is the pivot column? The pivot column will turn out to be the column that has the most negative item in the bottom row. All right, then we're going to look for a pivot row, and that's going to depend upon the things in the pivot column. If the things in the pivot column are all negative or zero, then we stop. There is no optimal solution. So there's two ways that we stop this process. Either there are no more negative things in the bottom, or we still have some negative things in the bottom, but all of the items in our column are zero or negative. So the whole process just keeps circling around until eventually we're going to stop. And that is either we find it or it doesn't have one. So that's kind of general, nebulous, and doesn't make any sense. So let's look at some specific homework problems. Alright, so we start off here in problem 1. We have something to maximize. Alright, there's the item that we'd like to maximize. We have a series of 3 constraints. The last 2 constraints just say it's in quadrant 1. So the first step is going to be to introduce slack variables and to organize everything. So let's scroll up here. So here are the constraints. Here's the thing I want to optimize. All right. We introduce the first slack variable to make it equal to 6. The second slack variable to make it equal to 15. The third slack variable to make it equal to 18. You move the 2x1, the 3x2 to the left, making them negative, and here's p, and it's equal to 0. Now carefully we make our matrix. Alright, so this is the column for x1. This is the column for x2, s1, s2, s3, p, and the right hand side. So I'm just grabbing off the coefficients. -2, 1, 1, 0, 0, 0, 6. I do this for each of the rows until we fill out the entire matrix. There's typically a line. This line separates the bottom row, and this line reminds me of where the equals was. So we first look for the pivot column. I'm looking along the bottom here. I'm looking for the item that's the most negative, and that's the -3. That gives me this pivot column. There are 3 rows, so which one is the pivot row? I take the right hand side and we divide that by each of the items in the pivot column. So 6 divided by that 1, 15 divided by that 1, 18 divided by that 1. I look at each of these quotients. The smallest one is the pivot row. That's why I have it boxed here. So row 1 is the pivot row. Our goal after we find that, so here's the thing I want to focus on. I want to use it to make a 0 there, to make a 0 there, and to make a 0 down there. Long and tedious. So -1 times this plus the 1 would make a 0. -1, add that 1, makes a 0 in row 3. I get rid of the -3 by multiplying row 1 by 3 and adding it to row 4. So let's scroll up a little. And so you can see what I'm talking about here. Here's -1 times row 1. Here's row 2. Here is the new row 2. So this is new row 2. This is new row 3. And finally, this is the new row 4. Again, just 3 times row 1 all the way across, adding that into row 4, and I make a new row 4. Putting all that information together. Okay, here's my new matrix. I again scan the bottom. See, we've looped around that flow chart. Do I still have a negative in the bottom row? Yes. Therefore, this becomes the pivot column. Pivot row. Well, let's see. 6 divided by a -2. That's not possible. Anything that's negative, we ignore. 9 divided by 1, 12 divided by 2. 12 divided by 2 is 6. That's the smallest of these two. Therefore, this becomes the new pivot row. So my focus is on this 2. Alright, so I'm going to use this 2. I'm going to make it into a 1 first, and then I'm going to use it to make some zeros. So here's the 1. I'm going to use it to make a 0, a 0, and a 0 underneath. So 2 times it, add the -2 is 0. -1 times it plus this item would make it 0. 8 times 1 is 8, add a -8 is 0. So again, I'm scrolling up so you can see here are the prescriptions for how to generate my new row 1, new row 2, and my new row 3. Alright, we collect all that information together. Alright, so here's my new matrix that has all of the new rows in it. I'm looking. Is there still a negative in the bottom row? Yes. Therefore, I would have a new pivot column. But wait, if this is the pivot column, so here is where I'm thinking is my new pivot column. But each of the elements here is 0 or negative. That led us to the branch that says stop. There is no optimal solution. Yes, I know that's frustrating. We did all of that work just to find out that the answer is there's no answer. All right, question 2. Similarly, I have something to maximize. So here's my item to maximize. We have a series of 3 constraints. So again, I need to organize. So I've got 3 constraints, so 3 slack variables. That's the amount that I would need to add in to make it equals. This last row, I simply move x1 to the left, move 2x2 to the left, giving me this row involving my thing to maximize. So, taking that information and again putting it in our matrix. Again, just grabbing all the coefficients. If something is missing, they're zeros. All right, so organizing all that, I look and I say, oh, there is a negative in the bottom row. Therefore, I get a pivot column. The pivot row, oh, there's a -4 there, so I can ignore that row. And I only focus on the 1 and the 3. 2 divided by 1 is 2. 8 divided by 3 is 2 2/3. So the smallest number is the 2. And, well, where did that come from? That came from row 1. So here's the element I'm using. I'm using it to make a 0, make a 0, make a 0 underneath. Yes, this is long. It is boring. It's so easy to make a mistake. You must be organized and careful in your calculations. All right, so there's the plan of all the things I did to make a new row 2, a new row 3, and a new row 4. So stop the video, make sure you understand where all of those numbers came from. I then put them together in our matrix. All right, so looking at my new matrix, I'm asking, is there still something negative in the bottom row? Yes. So I need to find the pivot row. Well, looking at the things in this column, 2 things are negative. I only have 1 item that's still positive. Therefore, this becomes the pivot row. I'm going to make it a 1. Simply divide everything in the row by 2. Alright, now that that's done, I need to use it to make a 0, make a 0, and make a 0. And again, the prescriptions are there for how I did that. So again, pause the video, make sure you understand why I did what I did and why it looks like that. Alright, and then when I put that all together in my matrix, what do I notice? There's nothing that's negative in the bottom. All the negatives have gone away. Therefore, we have reached the optimal solution. Well, what solution? Well, this number in the bottom here. That is the optimal. So at our x1 and x2, P is going to be 5, and that's the maximum over our entire region. Now, where did these numbers come from? Well, remind yourself, this was the x1 column, this is the x2 column. There's a 1 there. That's in the x2, so x2 is 3. x1, here's the 1, and that says x1 is 1. Hopefully this is making a little bit of sense. Question 3. All right, question 3, I have one thing to maximize. Okay. This is a short problem. We only have one constraint. So I'm only going to have one slack variable. All right, so that's easy enough. Manipulate your maximizing P with x1 and x2 on the left, and now put them in your matrix. All right, I'm looking at the bottom row. I'm looking for the item that's the most negative. Well, that's minus 24. And that is the pivot column. Well, there is only one row, so that is the pivot row. I'd like to make a 1 there, so I'm going to divide that row 1 by 2. And so now I want to use this 1 to make a 0. Alright, and so you can see we did that. And now I'm going to update my new row 2. Well, looking at row 2, I'm seeing there's still a negative down there. Okay, well, there's still a negative down there, therefore this is the new pivot column. I want to make a 1 there, so multiply this row 1 by 2. Okay, now I'm going to use that 1 to make a 0. So simply multiply the row by 2 and add. Alright, that's what I've done here, and this becomes my new row 2. And if I put that into our matrix, alright, well, there's nothing negative in the bottom. Therefore, we have reached the optimal solution. Well, where is it? Well, first off, the optimal is P is 56. So now where was x1 and x2? Alright, well, here's x1, and that's a 1, so x1 is 4. Alright, well, x1 is 4. Alright, well, now what was my thing to optimize again? That's way up here at the top. We had P is 14x1 plus 24x2. And we just said that x1 was equal to 4. Alright, so if x1 is 4, 4 times 14 is 56. And if that's optimal, that must mean then that x2 is 0. And that's our final conclusion here, that at 4, 0, we have maximized P to have a value of 56. So hopefully this starts starting to make a little more sense. Again, you just have to be very, very careful in all your multiplying and adding. I know you can do it.